Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Ridwan bin Adrin Ridwan. Today I will do a demo for lab 4. For the first one, we will do the first procedure, that is we must to do the board plot from the circuit given. So we will derive and put in the derive, and we get the last answer that is here. That is numerator is 0.1. Denominator we get 9, 3 and 1 for the s power of 3, power of 2 and power of 1. So we put this value into the MATLAB at here. So we put for the numerator that we get from the answer, that is 0.1, and this is for power of S3, power F S2, and this is power S1. So this is for power S0 that we don't have at here. So we just put a zero number at here. So we will put the G equal to TF for the transfer function for numerator and denominator. And we want to do a board plot, we just put the command board G and we will run it. After we run it, we'll get this graph, and we want to see the value that we want to find. So this is the value information that we get at here, and it also at here. So at here we see it show the gain margin value and also phase margin value. For this phase margin value is from here, and from here the value is 70.8. So for the gain margin value 10.5 is from here to here. So after that we want to find the WG for the frequency gain. Like here gain crossover frequency WG. We just from the crossover at here, and we just find the point at bottom that we get, that is at here. So at here we get the frequency of 0.15 at here. So after that we also want to find the frequency WCP. So at here, and we just see the value at here is 0.33. So after we get this information, we must to find whether this is board plot is stable or not. So at here we see that this board plot is a positive phase margin, and also at here we shown the positive gain margin. So with the characteristic of these two, it shown that this board plot is stable. So this is the value that we get. And after we do and we must to do a hand by hand for the board plot, that is this same, quite same with the simulation. After that we'll do the simulation for number 4 procedure. So number 4 procedure, at here we see that here we just same like for the first one we do, we just the value that we the value at here, all we will substitute with the value that assigned to every student, like at here. So after, like in the calculation, we see after we do the calculation, so this is what we get. So this is for the k equal to 50. For the first value, that is 100s plus 300. So this is for, like at the first one, like we said, at top is the numerator, and at the bottom is the denominator. So like at the first one, we just place this value and in the MATLAB. So with this, like in the question that is have 103. So this is as power of 1, the s power of 0. So we just put as 103, 100 and 300 at here. So after that we put the denominator value, that here we get that is 1, 52, 30, 327 and 550. So we just put in the MATLAB, same like in the value. So the S power of 0 you don't have, we just put 0 at here. So like in the first one, we just put the G equal to transfer function, the numerator, denominator, then we plot it. We do the dot plot. So we just run it. So we get this graph. So like in the first one, just the same. We just show the value, all value. We we just at here time we can see at here, we can see at here. You can see this gain margin. This is the first margin. This is a positive first margin. If the positive margin, so this graph is stable. So for the next like in the procedure, it say we use the value of, we must do the value for value at here 150 500 and 1500. So first we already do the 50, so we will do the 100, 500 and 1500. So we just change the value of k, like in the calculation we will do the calculation and we put the answer in the MATLAB. So like this, so this is k equal to 100, so this is 200, 600 for the numerator. Denominator is 1. Uh, so when we change the value of k, the just the numerator will change. The denominator will not unchanged until the end. So we just change the numerator. So this is 200, 600. So like here we see, so this is 100, 300. So we just change the numerator 200, 600. So we just run it. So like in the same one, so we just show the all the information like this. So this is positive margin, positive gain margin. So this is stable. So for the next one, we just for the 500 value that we do calculation, we get this in 1000 and 3000. So we just put in the so just numerator that change. So the numerator will just not change because the k value that we change it just effect on the numerator. The numerator will unchanged until the end. So this is the 1000, 3000. You just run it. So we'll get same. We will show the information that we get. Same that here. So it also shown the positive first margin, a positive gain margin. So the uh graph this box plot is stable. For the last one, we just here we do the calculation and we get the 3000 and 9000. So we'll just change the numerator value 3000, 9000. So we just run it and we also get same box plot. We just show the information. So we show the information. So this is the positive gain margin, positive first margin. So this is a stable plot. So all the same, we just change the k. So the just numerator that change, or for the numerator it will unchange until the end. So thank you.